Hello everyone, welcome back to the Cutting Edge stage and to our penultimate session in this track and indeed of the conference itself. We're going to be talking about scaling voice technology, and with that I'm just going to go straight into introducing our moderator for this discussion, Catherine Breslin, Solutions Architect at CobaltSpeech. Please join me in welcoming her to the virtual stage.
Thanks a lot, Gemma, for the introduction. And it's really great to be back here on the cutting edge stage at CogX. I'm really excited to be here again. I'm thrilled that we've got three amazing guests today who have keynote talks talking about their real world experiences in scaling and building voice and language technology for the real world. So to start us off, we have Dr. Heidi Christensen from Sheffield University. She's a senior lecturer in computer science. We're followed by Andy Webb, who's head of voice and AI at the BBC. And we're finishing up with Helen Lyashenko, who is Software Development Manager at Amazon Alexa. So without further ado, I'd like to introduce Dr. Helen Christensen, Heidi Christensen.
Hello, everyone. Thank you very much for inviting me. It's really exciting to be on this stage. I realize I'm the academic input to this session. So my slides here today is I'm going to talk about scaling voice technology, the healthcare domain case, if you like. Let me just. So first I want to talk a little bit about what state of the art looks like in voice technology, although I reckon you will hear a lot more about that later on in this session. So obviously we're now quite used to having a lot of usable and very used voice technology everywhere. So there are apps we can talk to, they will understand us sort of, they will generally assist us when we're communicating. We could have live captioning and video calls like this one. We could get away with speaking to robots, etc. So mainstream speech tech has matured a lot in the last decade. There's lots of successful applications and they're really pushing boundaries of conversational interfaces. So we're really here to talk about scaling voice technology and how we get the next 10 years right, if you like. So I'm going to question a little bit what sort of scaling we are talking about in this talk here. There are a lot of options of factors we could scale. So when you're training, for example, speech recognition, certainly looking at the number of hours you might have in a speech corpus is something you might do to kind of scale things up a lot. So Amazon recently kind of talked about how they're now training acoustic models with millions of hours of speech. That's definitely scaling things. Or you might think about how you could scale the number of voice-enabled personal assistants, for example, that are sold. Again, huge amount are already out there. I'm going to cut to the chase in this talk here and give you the talk's conclusion straight away, which is that I think we also need to talk a little bit about scaling downwards, if you like. So with this, I want to talk a little bit about how it's really important when we scale upwards, we also start looking at the details and getting the details right in healthcare domain when we're talking about that case, if you like. So this is about getting personalized solutions, solutions with detailed information from clinicians, etc. So all of the cutting edge or current cutting edge is for typical voices. So it's typically kind of targeted at generally healthy and well people, not for the too young, not for the too old. But I'm really interested in this sort of cutting edge corners, if you like. So what can we do for people who are not typical, not well? Perhaps they might not know that they're not well, but what can we do to kind of help them with technology? So to sort of put this in perspective, if you like, my research interests are particularly on pathological speech. How can we detect pathologies? How can we treat them? And in general, how can we break down some of the barriers for this group of people when they are accessing, for example, personal voice-enabled assistants? So this is really an equality and inclusivity issue, as well as being an interesting research topic. So why is this important? Well, we could look at some of the conditions that I work with, people who have these things. And for each of these conditions, people are affected in different ways through different lifespans. So something like cerebral palsy occurs at birth when something goes wrong. At the moment, it's about 1 in 400 births in the UK, and you are affected for life. So you will have often severe mobility problems, and it also affects the way you speak. Another big group of people I work with is people with dementia. So this affects about 850,000 people currently in the UK. And it's also now the most common cause of death in England and Wales. The risk increases with age, and it's a slow onset. So you might not know for quite a long time that you have early signs of dementia. Then there's something like stroke. People estimate there's about 100,000 cases a year. These are often relatively young people who are living active lives. And so this is a huge life-changing event. And we really need to help them to get back into living active lives again. And then there's something like mental health. It's estimated that around 1 in 4 people in the world will be affected at some point in their lives. This is a condition that may come and go. You might feel well for some years and then less well for some time. So how can we get technology who can bring different life quality improvements in these cases? So some of these things are slow onset, some are for all of your life, some are for the end of your lives. How can we kind of make things better with technology? So in this talk, given we just have 15 minutes, I'm going to dip into 3 research case stories, if you like, from my team, what we're working on. First of all, disordered or dysarthric speech recognition. Secondly, a little bit about how we might analyze conversations, what sort of things we can do in that field, if you like. And finally, pathology detection, such as dementia. And I'm going to talk a little bit about what we've achieved, what's left to do, and what the kind of main challenges are, if you like. So dysarthric speech recognition. The motivation here is that people with atypical speech, this is often caused by long-term conditions like cerebral palsy, or it could be a sudden traumatic brain injury, stroke, etc. For these people, it's suddenly really difficult to communicate effectively, both with humans, but also with machines. And on top of that, they often have mobility problems, so they can't really very easily use a keyboard. So they could really do with having speech recognition available to them in a way that it's now available to most other people. But of course, they can't use mainstream speech technology. Is just not tuned to their type of voice. So the sort of applications you can imagine if you solve this research problem would be dictation systems. It would be so much easier for them if they could speak as an input to text generation. Speech recognition for controlling smart home devices, so something like the Alexa system, for example, or speech recognition for communication aids. So you have a voice input, voice output technology would also be really useful. So I just want to show you a little bit about the path of mainstream ASR starting back in 1970 and how you went from kind of single word command and control systems to voice-enabled personal assistants, and now we have much more interaction systems. In the world of dysarthric ASR, we're basically still up in the very beginning. We are only just moving away from the kind of isolated word case. So what are some of the things we can do to make systems that work for this group? We definitely know that we need to personalize systems. So we need to think about what sort of words are we designing them for. We can't have them say any words or any phrase. It's often necessary to cut down to really limited amounts of words. We also know that we need to tune the models to the specifics of a person's voice. Another thing is that we have to find out in the sort of research space how we make use of very little data. So it's definitely not possible to record millions of hours like Amazon can do. In fact, some of the databases we have as little as 20 minutes per person. So we really need to work out how we can make use of this, how we can leverage typical speech databases, explore alternative representations, use conversion techniques, etc. Common for all of these things is that they do work. However, we are still far off mainstream performance. So we're far off being able to give a phrase-based dysarthric speech recognition system to someone. The other main thing I kind of work on is analyzing conversations. And this goes from anything like analyzing, finding out emotions when people talk to each other, their goals, etc. One of the big aspects of this is communication aids, where people such as the lady here that I've worked with for probably 10 years, she's using a communication aid to try and help her speak to people who don't know her well. People know her well, they understand her, but most people don't. But they're really hard work. They're not really conducive to having a natural interactive conversation. So the solutions are, there's lots of different things we can do. We can have better input methods. If we could recognize her speech, that would be much better. We also look at how we could recognize the full message, not just what she's saying, but how she's saying it. And we can make use of context, who she's speaking to, is she at the GP, isn't she in a shop, etc. All of these things you can kind of add in. Another aspect of conversation analysis we're looking at is to try and unpick what happens, for example, when a psychotherapist is speaking to a client, and try to understand the dynamics of a conversation. We know that if people can stay with the sessions and come back for all of the sessions, there's a much bigger chance of having a good recovery. So we're trying to see if we can automatically try and detect when things go wrong. So we're looking at things like depression, anxiety, synchrony, is there empathy expressed, etc. So we kind of know that speech analytics like this can reliably track all of this in the lab, if you like, in research experiments. However, we really need to learn how to combine all of this for real impact. So how do we make a system out of this that is actually useful for people? And how do we find out what users really want from such systems? And then finally, there's a lot of work going on at the moment to try and see how we can kind of automatically detect signs of pathology in a person's speech and language. So the motivation here is that people with cognitive impairment, for example, as a result of Alzheimer's disease, they often show really early signs of a condition in their speech and language. So this could be up to a couple of decades before the doctors were kind of detected. If we could detect these automatically, we could really improve treatment, we could save time as well as money. And you could imagine you could screen the full population for things like Parkinson's disease. You might stratify people with memory problems. You might go into looking at long-term tracking of people with mild cognitive impairment. So there's lots of applications, if you like, of this, if you could get the basics right. And we know from research that people have looked at, for example, Iris Murdoch's books. So going back 10, 20 years from when she was eventually diagnosed with Alzheimer's, you can see that her books are less complex. And the same with Ronald Reagan's speeches. So he was famously diagnosed with Alzheimer's about 5 years, I think, after he left office. But you could actually see it in his speech much earlier than that. So what have we tried to do? So we tried to look at the sort of conversation that a doctor has with their patients as they come into clinic, and try to find out whether we can automatically capture some of this. We really need to have an easy to use and quick and reliable test for people to take at home, because it's very stressful to come into clinics, it's very costly as well. So we've tried to see how far we can kind of get with automatic methods in this area. And we've looked at various automatic methods, including replacing the doctor with a virtual agent. So currently this system is the one you see on the right here, CogSpeech. It will ask a couple of questions of you, ask you to do a few tests, and then kind of work out whether you are at risk of developing dementia and should come into clinic. And these are the sort of questions that we look at. So things like, well, if you come in today, what are you hoping to find out? Long-term and short-term memory questions. So we're really hoping to be able to track people's cognitive health over time. We have a lot of recordings at the moment. And of course, with current sort of data-hungry algorithms, we need a lot more data. But we are able to show good accuracy, which is good. They're already equivalent to existing standard tests. People like talking to the head, which is good. They find it more friendly. It's less kind of stressful than some of the other tests. And it doesn't take too much time, so it takes about 11 minutes on average. However, we still need more data, and we need to explore lots of things, for example, things around language and accent diagnostic tests. And we need to test a system like this in GP clinics, for example. So this was a quick run through sort of 3 research cases, if you like. There are still many challenges. There's a lot we can already do. And there's some key themes you've probably picked up on. So clearly for all of these areas, it requires a big interdisciplinary team behind the scenes. So I regularly speak to neurologists, psychologists, linguists, etc. This is definitely not just something you can do as a computer scientist sitting in your own lab. All of these solutions need personalization. So this is going back to the scaling up by scaling down into the details, if you like. all of these areas in the healthcare domain suffer from having access to too little data, really, for porting the methods we know work well in the kind of mainstream domain into this area. And we really all need to kind of be aware of how we show real impacts when we move out of the lab. So this is where I feel like university academics really need to work with industry to make that leap out of the lab. So in summary, we have very promising research results. However, we really need to work well with industry and universities to collaborate to put this technology in the hands of end users and clinicians. And I feel universities have a big role here because they have access to this very interdisciplinary team. So to go back to one of my very first slides where I gave away the conclusion. So as you saw in this area for working for these people, we really need these personalized solutions and solutions with detailed information from clinicians. So all of these systems, we've worked closely with clinicians to learn about what happens, what are they looking for. And in terms of the next 10 years, I really hope we can show impact from this cutting edge corner, if you like, technology. So thank you very much. And I think I will pass over to Andy now, who is at the BBC.
Hello, everybody. Welcome. Thank you very much for that, Heidi. It's really interesting to hear. I'm going to be talking to you about scaling voice experience through a slightly different lens, through that sort of business and sort of strategy lens. When we think about scaling, we obviously start to first think about starting off very small, like what are your beginnings? And how do you start to grow your involvement within voice? And how does voice start to play a more important role within your organization? So I'm going to take you through essentially what was the BBC's journey. I started in voice about 3 years ago, so I'm a bit of an old hat almost in it now. And obviously we are a huge publisher onto platforms such as Alexa and Google. And not only that, last week we launched our own assistant as well. So I'll take you through the journey through that and thinking about how we had to sort of scale to be able to work in that kind of evolution. We think about the first question. I'm just going to start to share my screen. If we think about why voice is important, it's almost after sort of 30 years of kind of graphical user interface digital experiences that we've had, they've all started to sort of plateau in terms of that user experience a little bit. If you think about some of the differences that exist, lots of the websites are still sort of quite sameish. They've got categories kind of like product pages, about us, contact us, checkouts. Mobile apps have got the quite sameish now a bit as well. There's scroll up, scroll down, swipe left, swipe right. It's news feeds that sort of dominate it. And if you think about TV applications as well, they've started to come a little bit sameish as well. There's genres, there's categories, there's A to Z essentially. We've sort of reached the limit of just how good we can make these branch tree user journeys to be able to get people where they want to be. Now, we've done a really, really good job of that, but I don't think anybody would kind of disagree that we're now up against this law of diminishing returns that really sits in there. So kind of enter voice and natural language. So we believe voice will evolve to become this benchmark for great user experience. Not necessarily by itself. Voice will deal with that kind of audience shift that now exists into ambient computing. You know, we're living in smart homes, we're driving smart cars, we've got smart headphones, smart watches, and we're surrounding ourselves by that kind of computing power. But it also has the potential to sort of truly revolutionize the user experience of our already existing large-scale digital products, as that voice user interface and that graphical user interface start to build tighter interdependencies between each other. And we'll really start to, again, see diversification start to come through in digital experience, and this whole new wave of innovation as we sort of explore great user journeys. Now, that cut through of navigation that voice facilitates will really transform our audience experiences, but it will also have effects on how brands are reflected themselves online. If you think about it, we spent 20, 30 years building these incredible brand experiences, really rich, surrounded by content. And suddenly you can just turn up and say, oi, play Radio 1. And you can just cut straight to that piece. So there's pros and cons about voice, and essentially it's always this balancing act now between sort of discoverability and ease of use, and that the ability for us to represent our brand effectively online. So for us, our sort of starting point was really to go back to the BBC's original mission. Our creative and editorial question is always how to inform, educate, and entertain in a conversational medium. Inform, education, and entertain is the BBC's mission. And that creates then the business and technology question, which is how do we create a sort of a scaling strategy that enables that conversation for us to take place. So we started off with this sort of 4-point strategy that we presented into the business, and you know, all the best strategies keep things very, very simple. And for us, we wanted to start off with a more modest investment around here and start to think about things. So for us, it was to start to invest in conversational design. And if you think about conversational design, you know, we're very good now at, at talking to users when they have a screen. Take away that screen and we have very little experience of talking to them, or indeed when they can talk back to us. So that gets you thinking again about the differences that exist between a graphic user interface and a voice user interface. And one of the first things you come up to, and that starts to challenge you, is you realize that the internal naming conventions you've been using within your business for a long time actually become quite difficult for a natural language processing engine to be able to sort of get through. If you quickly go to, you know, the BBC Sounds website, you'll see on there we've got Radio 1, we've got Radio 1 and Radio 1 Extra, we've got Radio 1 Anthems, we've got Radio 1 R&B Anthems, we've got Radio 1 Dance, we've got Radio 1 Breakfast Show, we've got Radio 1 Breakfast Show Big Best Bits. So it's easy to really see how natural language processing engines can start to sort of run into problems when you've got that repeated use of words that's used to describe sort of differing assets that exist within your business. So actually one of the simplest tricks that helps you be able to scale, helps you get all of your content onto there, is not necessarily to work with the tech and refining the tech a lot to be able to sort of distinguish between various pieces, but actually to think about it from an editorial perspective and just to change your naming conventions around the content, and to have that foresight that as we develop new programs, that the names should make them searchable within a digital experience and within a voice-first experience. We set this kind of criteria as we wanted to get up to the second level, that really sort of justified spending additional money and sort of scaling even more within voice. Because one of the biggest mistakes people make is sort of overscaling their products at the beginning when demand is low. But these numbers kind of really gave us a lot of confidence to be able to move on. So we launched our first music skill on Alexa, and we have a fantastic relationship with Amazon, who sort of helped us go through and helped us work through all that kind of editorial naming conventions to make our assets available. And to date, you know, we've played over 1 billion pieces of content, 100 million news briefings, we have 2 million weekly users who exist across our voice assistant real estate, and at the moment we've really just kept it focused on the UK. You know, globally the BBC has probably about 450 million people a week who kind of consume a piece of BBC content. So actually our largest audiences actually exist outside of the UK, which we haven't even approached yet. So you can clearly see the potential that exists for doing what we do already now and not having to sort of overinvest, and the ability for us to scale that hugely to new audiences. The next stage that we kind of went to as we start to move this was to think about how do we start to deliver these new experiences that wow the world? And what that really means is how do we evolve products that start to maximize the use of the format that is available? We learned very much from when we took content from print and tried to put it on the web that it didn't really quite translate in that way. And likewise is the same of when you take a program that was designed for, say, radio, and then try and put it into an interactive voice environment, it doesn't necessarily sort of work as well. It's good if you're using a smart speaker or something just to replace your DAB radio or something like that. But if you actually are thinking of it as a piece of content and you really want to maximize the benefits out of it, you have to start to design for that new format. So for us, one of the things we needed to do was to think about, to do that at scale, we need to start investing in tooling. because tooling is actually what takes content production out of the hands of software developers that are very expensive and starts to put that back into the hands of content producers and those creative people who develop our programming and develop our services, who audiences have built up that long relationship with for us as well. So this tooling, I guess when you go back a few years ago, was this sort of thing that you had to approach with a lot of caution. First of all, really just because of the market that was existing around it. The market was very, very nascent at the time. I don't think there are any tooling companies in existence that were in existence about 3 years ago that haven't been acquired or haven't changed hand. And of course, that's meant consequences for people who built their experiences on that tooling. So for us, as well as that, there was this kind of regulatory environment within which the BBC sits. You know, we are a news organisation. There are various rules in various domains around the world about where we store our content and have that available. So for us, it made sense to start investing in our own tooling. So we started to create this tool that basically just allows editorial staff to be able to drag and drop and to be able to sort of create workflows and processes to be able to sort of publish their content out. And there's a number of really good tools that are available out there on the market. But for us, we still have our use case that sort of determines that we need our own. Now, this let us start to work in a number of experiences. And the first use of that tooling, the first thing where we allowed editorial teams to suddenly create experiences themselves without the software engineers playing such a huge part in it, was around the Alexa launch for children's skills. And we were one of the initial launch partners for that. And today we still maintain this kind of 5 interactive brand games that were made completely by our editorial teams. We have sort of 25 children's stories that exist on there, and a number of sort of music and song anthems that go through. And one of the other things that enabled us to do was to bring our audiences closer to our broadcast domain. So most of the editorial staff who work in our team essentially come from strong audio backgrounds. They come from program making for radio. So there was a great opportunity to start to bring audiences much closer to our traditional radio output. And radio within the UK is still the single largest form of content, new content discovery that exists anywhere. So it really made a lot of sense to be able to bring those two together. So we did this great trial that was, again, produced on our tooling by our editorial teams who worked with the Radio 1 Breakfast Show to be able to bring a live experience where Greg was playing with his guests in the studio, and audience people could also play alongside online as well. Through their Alexa voice assistant. And it met with this sort of really terrific response. It really cut through with sort of young audiences as well. So we started to show, again, that, you know, once we developed the tooling, we can start to scale our involvement in voice a little bit more and a little bit more. Now, you do start to run into some problems at this stage. And that's because when you start to build deep, rich experiences, naturally, what you really want to do is start to publish them to multiple platforms. But all platforms have rules. All platforms have sort of things like reserved naming conventions that exist on them. And the problem is, all of these rules are not the same. So often you have to build a slightly different version of your experience to work on another platform. And that's okay at small scale. It's not terribly efficient in resources or in the kind of marketing spend you'd have to do. And if you want to achieve absolute consistency in experience, you have to design for that from the beginning. And often that means you can't then exploit the full benefits of each platform because you've designed for the lowest commonality that exists across all of those platforms. So, and then you have to think again, what happens when more and more platforms start to become available onto the market? You can't scale engineering teams that have bespoke knowledge within just one platform and then another team that has bespoke knowledge within another platform. So that led us on to the sort of the third stage of our sort of our 4-step strategy. And in order for us to sort of take that, the reality is you have to say we had to take a bit of a leap of faith. There were a number of things that we had to believe would come true to be able to do this. We had to believe that voice was a long-term investment that was going to be paid back through better user experience and improved distribution. We had to believe that there will be many voice assistants in the market, and that this is essentially a future trend, and that the only way we could scale in a reasonable, fair, and non-discriminatory way would be to seek a new method of distribution. We had to believe in coexistence, and the future will not just be one person talking to one assistant on one device. Consumers will still seek out the brands that they kind of trust and love. You have to believe in complex use cases as well that will require greater brand control and depth of conversational design. You need to believe in that depth as well as the breadth to go beyond simple distribution. And so this story broke last year, our own conversational assistant that allows us to address those scaling challenges. It allows us to deliver consistency and experience for complex interactions. I should say we still firmly see a world where we support the breadth use cases through distribution on platforms such as Alexa. And we have some kind of interesting plans in the pipeline for that. However, this also develops the necessary technology and APIs that allow us to democratize the natural language interaction across our existing digital real estate, which is what I discussed at the beginning, those interdependencies that will start to build between the sort of voice user interface and the graphical user interface. Simple example would be incorporating natural language search or hands-free use cases of mobile applications. So we launched a scaled-down version of Beeb last week, and really it's about testing lots of the sort of the plumbing that we've got going in, and making sure we're able to bring forward much richer use cases throughout the rest of the year. So scaling beyond publishing, so one of the lessons we've learned is tough. Building conversational UI is tough. If you look at all of the companies that sort of lead the market in this space and the resources they have allocated to it, you have to kind of believe in this one other thing if you're going to put your foot into that, and that is one of partnership. There are incredible high barriers to entry, although the technology is starting to become commoditized relatively quickly afterwards. And successfully scaling that means that we have to think of our digital services. Our future digital services will now be developed in partnership with technology providers, either big or small, who have kind of expertise in kind of the components that you want to plug into the pipeline of technology. And what becomes important for us is to maintain that actual pipeline and not the component parts themselves. So owning the pipeline is really what allows us then for each given context to assemble the right amount of component parts. Those that are kind of being provided by external providers, such as speech recognition, natural language understanding, natural language processing, language models. All of those can be provided by other people. It's not necessary or relevant for us to develop a core competency in them if we think they're going to start to become commoditized in sort of relatively short period. There are some use cases where we see open source, things like open source language models still being quite useful to us, or co-development of language models. And that's because, you know, the BBC, we generate content in 42 languages worldwide, and it's not necessarily all the common languages or the languages that would have a lot of commercial interest around them as well. So we do things like Hausa or Somalia and lots of underrepresented languages in terms of like the global economy. So for us, we just want to make sure that we don't become bogged down in the technology, which is very, very easy to do, but more just to become concerned with the application and the assembly of what drives scale. So coming on to the fourth sort of point that exists there, there's one thing that will probably really drive scale ultimately, and that's interoperability. So we can kind of regard the coexistence that sort of Jeff talks about here and has been on stage talking about, and you know, we've seen the demos between Alexa and Cortana interoperating between each other. But we have to kind of view coexistence still as really a first step towards full interoperability, and that is the piece that will sort of drive real scale in where we go. So coexistence is a practical problem. So technically that's reflected in how many kind of wake words can be supported and the diversity of the frameworks and the performance of the edge processing equipment to recognize those wake words and to be able to route a user's utterance accordingly. but also
I'm going to jump in quickly and just interrupt you there for a second. And I think this would be great to continue in the Q&A session afterwards. I'm just conscious that we're running towards the end of the session now, so I don't know if you have a wrap-up slide.
Yeah, sure. Okay.
So
there you go. How's that for a wrap-up slide? so really, we do see interoperability as kind of something that's going to go quite big. And if you think there's only two ways to make money in the world, as the old saying goes, bundling or unbundling. What that really means is that to achieve maximum scaling, we have to be prepared to play smaller parts in other people's conversations and let them play smaller parts in ours, essentially unbundling that full assistant experience. And that's going to require a focus on machine-to-machine conversation, bot-to-bot transactions, rather than just that kind of human-machine conversation that we have today. So it's not really kind of like as far out as it sounds, really, because it's really how the internet was built today. The internet is a connection of networks. Typically, you are served by your local network, and only when you need to go out for pieces of information do you actually go outside into the wider world and be able to sort of bring back that piece of information. So it's quite a similar concept to what we do. And we think ultimately those 4 steps is the kind of the trajectory of how we scale our experience and our involvement within voice. So I'm going to hand over to Helen now.
All right. Hello, everyone. Thank you very much for inviting me. I am thrilled to be here at CogX. My name is Helen, and I'm a software development manager working on Amazon's Alexa. I've been in the Alexa organization for about, well, almost 5 years now. And in that time, I've had the privilege of working on some really exciting technology. So what I'd like to do today is, I am sorry, but the device woke up. Alexa, stop. The power of, or the excitement of doing a live talk from home. Anyway, so what I'd like to do today is to share just a taste of some of what I've done over the past couple of years and hopefully inspire you to think about scaling voice technology in a different way. Think about a different dimension of scaling voice technology. So first, let's go back in time. When Alexa first launched, our devices looked a little bit like this. Not quite, I think this is a later generation, but what you're looking at is an Echo device, and you interact with it using your voice, and it responds with sound. The fact that this device enabled voice-driven interaction is what made it so novel, so futuristic, and that's what really attracted me to the organization. But these days, our devices tend to look more and more like this. They're not just voice in, voice out, but there's a screen, there's a visual element. That's because screens are actually quite useful. They can enhance the voice interaction by displaying additional engaging educational content. And they're useful because, well, sometimes the best response is visual. So if you ask, show me pictures of cats, which of course is a very critical use case, you need a screen to really deliver that experience. When I started at Alexa, I worked on question answering, which was very new to me at the time. It was, I really have to stop saying her name. I apologize, she keeps waking up. So yes, it was something that was really new to me, and I learned a lot. And then around the time that these devices with screens came out, I moved to multimedia. On a personal side, I love visual art, so moving into this visual space was something that was quite interesting to me. So I moved to the multimedia team, my team, and what we own is the systems responsible for enriching Alexa's question answering capabilities with visual content. Now, when I say question answering, I'm talking about interactions like how old is the Prime Minister of Canada, as opposed to some of the other things that Alexa is capable of doing, like playing music and controlling the lights in your home and so on. So my team is the one that delivered the kind of visual experiences that you hopefully see here if technology is working well. And for the purpose of this talk, I'm going to focus on images as opposed to other kinds of multimedia. So just a bit of background information. Question answering involves some natural language understanding. There's usually some knowledge graph that gets queried, and some other steps that are needed to generate the correct response. This happens first, and then our systems are asked to provide visual content for that response. And what we typically get as input is some semantic information, like a semantic entity, and then we use that to query our image corpus to identify what we think is the best content to display on the screen. So in the example here of who is Grace Hopper, the input would likely be a semantic entity representing Grace Hopper, and as output, we would return an image similar to what you see here. And in case you were wondering, Grace Hopper was a pioneering computer scientist and one of my heroes. When we started, our primary focus was on increasing coverage. And coverage is pretty easy to understand. It's a metric, and it's the percent of the time that Alexa's answers are accompanied by an image. Increasing coverage is fairly easy if you have a limited domain like music, for instance, but it's so much harder when you're looking at the entire question and answer space. Alexa is capable of answering questions about pretty much anything, which means that we need to have images of pretty much anything. That's a big challenge. So this is why we regularly assess our performance. We identify gaps and we take effort to fill those coverage gaps. And we fill gaps by identifying appropriate sources, licensing content, and ensuring that we can retrieve that content at the right time. So to support doing this at scale, we built an image ingestion pipeline. And some of the engineering challenge associated with this has to do with the differences between different sources and being flexible. In general, it's all about flexibility. So sources might have different access methods. For instance, one of them might give us a data dump, and another might have an API that we have to use to access data. Maybe there's a data stream, could be something else. There's also potentially differences in the semantic namespaces or annotations that they use, or maybe there's no semantic annotation at all. Maybe it's just an image and some text, or maybe it's just the bytes of the image. That's all we have to go on, in which case there's there's extra work required to extract meaningful information so that we can retrieve the right image at the right time. And also, depending on the source and the type of data being ingested, the pipeline has to be flexible enough to support arbitrary processing steps. So there could be different steps that we have to take at different times. So there's another element of flexibility. And these processing steps, they could be running different machine learning models or something else. So why do we need machine learning models? Well, I talked about coverage, and that's an easy metric to measure, to understand. a request comes in and either we're successful or we're not. And if we only focus on coverage, then we won't create the optimal experience. We're very customer obsessed at Amazon. So not only do we want to return an image, we want to return the highest quality, the most highly relevant image that we can. That's our goal. And one challenge we face is, how can we do that automatically? How can we tell that an image is relevant? How can we detect that an image is aesthetically pleasing or more aesthetically pleasing than another image? And if you think about it, how can we even measure improvement in quality? These are some tough problems that we have to solve. We continue to innovate in this space by applying the latest computer vision and other technology to deliver the best possible customer experience. And now I want to highlight some of these customer experiences, so I really hope that you're able to see my presentation. Otherwise, this really won't make much sense. All right, so these are all things that my team has delivered, and we're very proud of them. So the one that we're looking at right now, if you have an Echo device with a screen, then you've probably noticed news stories that tend to cycle through on the home screen. And when those first launched, the background behind those stories was the same as any other content. Nothing unique about it. We wanted to make that experience more engaging and more informative. So my team built the tools and did the integration that allowed those news stories to be illustrated with relevant, high-quality images like what you see here. So now each story has its own background and each image is related to the story, making the home screen that much more delightful. We focus on delighting customers with every interaction, no matter how small. When you used to ask questions about sunrise, sunset, or just the time in Tokyo, we used to give you a response with the answer on a blank screen. Now that answer is accompanied by beautiful images. If we have images of your hometown, we'll display it. If you ask for the time in a specific location, you'll see an image of that location. Question understanding, image ingestion, image querying, everything has to work together to make that possible. And okay, just one more. This one I'm really excited about. This was a lot of fun to work on. So recently, we started looking at events and trending content, something that requires really up-to-the-minute images to be impactful. We don't want to just return generic content. We want to wow our customers with something extra. And this is why when you ask about the Best Actress winner on Oscar night next year, not only will you hear who the winner is shortly after the winner is announced, but you're also going to see an image of that person accepting the award on stage on that night. I think that's pretty cool. So delivering this kind of up-to-the-minute, highly relevant, automatically detected and ingested content is an area that we're continuing to develop. And those are just some examples of the ways that we improve the customer experience every day. And there's always more new opportunities for us to improve and delight. So I hope this was interesting. Thank you.
Thank you very much to all three of our speakers there on the voice session. That was absolutely fascinating and so great to get three quite different perspectives from three different areas all around the same topic. And hopefully what's happened is everyone watching has had lots of shall we say, seeds being planted, and hopefully lots of questions coming up with ready for the Q&A session, which actually is going to be starting in 10 minutes time. So go grab yourself a drink, or go and run to the bathroom, or go and network, or do some tweeting, whatever you'd like to do, and then come back in 10 minutes time for the Q&A, which is still going to be all three speakers are going to be part of and moderated by Catherine. So until then, as I say, go and have a break, and then if you actually want to come back to the next session on the cutting edge stage, which is going to start at 6, if you're not coming to the Q&A, that's going to be on the future of computation, AI, ARM, and RISC-V. So you can come join that as well. 2 great choices, and I hope you will choose one of them from the cutting edge stage. Thank you very much.
Want access to more CogX videos? Subscribe now for free at cogx.co.